So the battery is labeled with 12 volts. The resistor is labeled with 4.125 volts. The left bulb is labeled with 21 ohms, which would be a resistance. And the right bulb is labeled with 1.125 amps, that would be a current. All right, so let's proceed to try to solve the rest of this. First of all, using my tip, that's not helpful yet because none of the rows here have two values in it. Every row just has one value in it. So I have to think of either the voltage law or the current law to try to help out. And in this case, I see that the voltage law is going to be helpful here. So this is a mixed circuit. There are aspects in parallel, but also aspects in series. So I'm going to trace out the first loop that I see. So I'm going to start at the battery. I'm going to go past the resistor and then turn down to hit the first light bulb and then go back to the battery. So that's what I'm going to call my first loop. I'm highlighting that in blue. And that loop, the voltage law says that every loop, the voltage gains, which is 12 in this case, has to equal the voltage losses. And there's two places in that loop where voltage is being lost, the resistor and the light bulb. The resistor, it says, takes away 4.125 volts. So therefore, the light bulb has to take away the rest. So let's say left bulb voltage. It's got to take the remaining number of volts. It'll be 12 subtract 4.125, whatever that equals. I believe that will equal 7.875. Okay, and the exact same thing ends up happening to the right bulb. So now I'm going to highlight a different loop. So I'm going to start at the battery. It's going to go through the resistor and now straight through the junction and then hit the second light bulb and go back to the battery. I'm doing it in green here. So this is what I'd call loop number 2. It has to obey the voltage law as well. So in the green loop there, I'll make a heading here. I'm going to call this the right bulb voltage. It will do the exact same thing as the calculation I just did. There are two loads in that green loop, the resistor and the light bulb. And the resistor is still taking up 4.125 volts away from that 12. So the other light bulb is going to be the same voltage. So if you're looking at your project, your unit project, and that circuit you have there, it's a little bit different. There's one extra resistor attached to the second light bulb. So that complicates it. And you have to deal with that as part of your project. But for this question, the answer for this is 7.875 volts as well. All right, now doing that allows me to proceed to get the resistance of the right bulb. So I just put an arrow there. I can get that value because using my tip, since I know two values in that row, I can get the third value. So I equals V over R. 1.125 equals 7.875 divided by R. So a lot of decimals here, so you probably want to use a calculator. You can accomplish solving for R by doing 7.875 divided by 1.125, and that actually ends up being a perfect 7, I believe. I'm just going to double check with my calculator here. Yeah, it ends up being a nice whole number of 7 ohms. Okay, next I'm gonna go for this blank here, the current of the left bulb, because I know the 2 other values in that row, so I can get the third value. I equals V over R. So in this case, it would be 7.875 volts divided by 21 ohms. You get that in the calculator. That gives me 0.375 amps. Okay, so I have 3 blanks left. Where do I go from here? I'm going to, I think if I can, clear, yeah, I can erase the highlighting in my circuit. And then I'm going to use yellow now. Okay, so what I just calculated, I'm going to label that in my diagram, 0.375 amps. That would be a current. That would be how much current is coming down the middle path. Whereas the amount of current going towards the right is 1.125 amps. You can see that in the other light bulb. It's labeled. So I know the amount of current going that splits up into those 2 pathways at that junction point. This is a junction point right here. So where did all that current come from? Well, all that current came from here. So the current down the top strand there through the resistor actually has got to be equal to the total current going through the other 2 pathways. So it'll be 1.125 plus 0.375. So that makes a nice 1.5 amps. So 1.5 amps had to be going through the resistor in order to be able to split up into the 2 numbers that we got for after the junction. So that's the current through the resistor. And you know what? Where did that current come from? Well, if you trace back a little bit more, it came from the battery. So that entire section we would have the same current. So the current through the battery as well would be 1.5 amps. That's the current law. The current splits up at the junctions. They'll go around, they'll recombine. Okay, they will recombine at this other junction to add up to 1.5 again and go back to the battery. Okay, so last but not least is pretty much the very middle. The resistance of the resistor has not been calculated yet. So I'll just, right at the bottom down here, resistor resistance. So I'll write Ohm's law. So the current is 1.5, has to equal the voltage of 4.125 divided by something. To get that something, you can do 4.125 divided by 1.5. I'll get that in the calculator. and that gives me 2.75. And that is my last value. That completes the solving of this circuit.